This is the second version of the video to prove the fourth bullet point under specific outcome number 1 for shape and space in Alberta's grade 9 curriculum, at least the 2016 revision of that curriculum. We want to show that a tangent to a circle is perpendicular to the radius at the point of tangency. That will require a little bit of calculus and a little bit of conics. So again, this is not the compelling argument, this is the proof. And the proof in this video uses calculus and other content that is beyond the scope of grade 9 math, as well as beyond the scope of math 20-2. So as a grade 10 student or a grade 11 student taking math 20-2, there's going to be a lot here that you are not familiar with. That's okay. There is another version with a compelling argument, which at the end outlines a much longer proof that you can do with math 20-2 skills. This version is here for the more mature student who's checking back at a later time in their academic career. So one of the key things to know is that if you have a circle, and again, we are zooming when we don't want to zoom. Really wish I knew how that was starting. Okay. So if you have a circle of radius r, and the center is at the points H and K, the equation that describes that circle is not a function, it fails the vertical line test, but it's x minus h squared plus y minus k squared equals r squared. And variables are case sensitive, so let me use that lowercase r to be consistent with our diagram. So this is our point, or our equation of the circle. And let's say that this point of intersection here is AB. In that case, the slope from the center to this point, which is y2 minus y1 over x2 minus x1, would be k minus b over h minus a. So that is the slope of the radius. Now, a tangent line would have the slope of the circle as it passes through the point AB. So using something called implicit differentiation, in calculus we can show that 2 times x minus h times an infinitesimal change in x plus 2 times y minus k times an infinitesimal change in y would be 0. Again, this is something that is not going to be comfortable for students until they're about halfway through Math 31, if not a little bit further. But the slope in calculus would be given by dy over dx. If we take this expression and cancel the 2's, dy over dx is our goal. In order to get there, we can move this term to the right or this term to the right. I think it's going to be a little bit easier for us if we move the first term. So that leaves us with y minus k dy equals negative x minus h dx. We can divide both sides by y minus k dx. In doing so, we get dy by dx. Our y minus k's cancel on the left, our dx's cancel on the right. That is going to equal a negative x minus h over y minus k. Just starting to look a little bit familiar. Here we just have the k's and h's first. But that will be equal to a negative h minus x over k minus y as well. When both are negative, we can multiply top and bottom by negative 1, which is a negative a minus x over, or sorry, not a minus x, that is a negative h minus a over a k minus b. So that is the slope of the tangent to the circle, or the slope of the circle itself, which is the slope of the tangent. Comparing them, k minus b over h minus a and negative h minus a over k minus b, the slope of the radius which is k minus b over h minus a, is the negative reciprocal of the slope of the tangent which we showed was equal to h minus a over k minus b. So that is using calculus to complete the proof. And it shows that, yes, these do have negative reciprocal slopes. So yes, the tangent and the slope are perpendicular. The key points here, the only pieces that we don't have in place, are how to turn this equation for a circle that we have here into the slope of that circle, which we have down there. So we need the circle equation from conics, which, now that you guys can see it, you could actually prove it yourselves by just using the Pythagorean theorem, right? X squared plus y squared equals r squared. So the distance between the center hk and the outer edge, the x is going to be, x minus h. The y coordinate is going to be y minus k. We square those. If they're equal to the radius squared, this satisfies the Pythagorean identity. This will be the equation of a circle. So the circle equation is one thing that we would have to pull from conics, which are not part of Alberta's curriculum. The second piece that we need to do this is how to turn the circle equation into a slope. So this first one needs knowledge of conics, and the second needs some knowledge of calculus. So that is the proof, but do not expect to fully grasp all the steps at the grade 10 level.